Very good morning to everybody who's joined today. This is Ross Evans, Field Marketing Lead for the UK Public Sector here at AWS. Really pleased to have you join us for today's part 2 of our Data Lifecycle series, which is entitled Preparing Your Data for Cloud Analytics and AI and ML. I'm super pleased to introduce Abir Roychoudhury, who is a Technical Business Development Manager here at AWS and a specialist in all things data warehousing, storage, databases, data preparation, and all the good things you want to hear about today. And sitting with me behind the scenes, we've got Charlie Llewellyn from our Solution Architects team. He is going to be manning the Q&A, so do feel free to ask us any questions that might occur to you during the course of today. There's a widget as part of the GoToWebinar software that allows you to ask questions, so please feel free to do that, and we'll make sure we answer those as we go. And if there's anything really cool and pertinent and challenging, what we'll do is we'll call those out at the end and we'll put them to Abir live at the end of the session. So that's enough from me. Very warm welcome to Abir. It's over to you, sir.
Thanks, Ross, for the introduction, and thank you very much, everyone, for spending your valuable time for the session. So good morning. So this session is really designed for introductory levels on AWS Analytics Services and how to really bring them together. Picking the right analytical engine is not always an easy task, and this webinar will provide you with a structured approach and while exploring AWS services on the way. We offer a range of analytical engines to match your several use cases, and that could address big data processing, data warehousing, ad hoc analysis, or real-time streaming, or even log analytics. So before we start, just a quick overview of the agenda. We will look at the public sector situation, give you an overview of what feedback we receive from our public sector customers, what blockers and challenges they're facing, and I'll walk you through a data lifecycle process in theory, and we will explore AWS services on the way that could help you. And then we will show you a quick demo on how all those elements really come together. It's really a simple demo for which we will use an open data set with climate data that's provided by Cornell through our AWS Open Data Platform. After that, I will briefly touch on some customer references and talk about best practices to secure your data lake, and end with some architectural guidelines before I open up the webinar for answering more questions. So, what do we actually observe in public sector? Many of our customers report that data is dispersed and difficult to access. So when it comes to looking at the data and ask questions, we see that business have a very siloed approach. So a data source per data source approach. So for example, we see typically a relational database where users are querying a specific data set, or in a different instance, data is extracted from that relational database and loaded into a data warehouse. And if you do any more type of analytics, that usually happens in isolation. So businesses are really struggling to bring different data sources together. And as they have different formats, some are at rest, some are in motion, it really becomes difficult to join them up and ask more elaborate questions. However, if you can overcome the challenge, you can enable your business with some really valuable insight. I'll give you a quick example. One of our customers, FINRA, who's a financial regulator in the US, ingested their unstructured data in form of documents, so brokerage reports, into the AWS data lake, which allowed them to convert the data into relational data using Amazon Comprehend, which is a natural language processing data service powered by machine learning. So suddenly you transform the static assets, static archive type data into valuable data where you can perform sentiment analysis or entity extraction. So businesses report that they have a limited view on what's going on in the business. Yeah. So most business queries are run on historical information. So typical BI, business intelligence type information from a siloed resource. But customers want to now use more advanced analytics to recognize patterns and make predictions to use analytics in their decision making. really to anticipate what may happen in their business. But the top 2 bullet points are usually related to the third one, which is resource constraints. And by that, I don't just mean IT assets, that's also related to personnel. So doing anything beyond the usual day-to-day business is limited by people's time and focus, which is sometimes invested on their daily firefighting. So implementing a more sophisticated infrastructure environment is strongly coupled with capital investment and complexity in order to provision those. So I'll give you a different example where a customer was trying to set up an on-premise Hadoop cluster to do some batch processing on their large data sets. Just setting up the Hadoop cluster would take them several weeks to months. So to the point where it takes a long time to get your cluster operational and running and create really business value tasks. So there's a great community available around those open source technologies, but it doesn't sometimes match the time to market objective. Also think about queries that only run for a short period of time. So a data scientist running queries to find results for the hypothesis, maybe only for a short period of time. And between those periods, you have a system being idle. There are many great open source products available, but building your own DIY solution may be time consuming and very costly. So all those challenges, the first 3 are also true in the enterprise world. But I think the one thing which is important in the public sector is governance and compliance. So this is really about the ability to ensure who is accessing your resources and apps has the right authority, and monitoring and auditing data access patterns and alerting you when there is malicious activity. And the platform itself should protect you against corruption, deletion, and manipulation, so inadvertently or maliciously. And this is really about the ability to ensure that all those services used in the process meet your compliance certification requirements as well. So this is really to quickly frame up the challenges we face. So what is the big data challenge? So first of all, the big data challenge is a data management challenge, and which we identify by the 3 V's. The first being volume. That could range from terabytes to exabytes to petabytes of data. And why do we need those large data sets? Well, we sometimes need large data sets to train an accurate model and get accurate results. And some examples could be human genetics, population stats, climate data, or even high-res images. What solution requirement does this impose? Well, you need a solution that can help you offline process that large data set, but you also need the capability to transport those large data sets across. And sometimes you just want to extract the information that is valuable to you. The second one being variety. So we touched on different sources, dispersed, and it is really about bringing those different sources and formats together. So that could be data at rest, data in motion, from SAMI to structured and unstructured data. Think about ASCII and JSON as binary data. Example data could be anything from a database to documents, and the solution requirement is really bringing those together. The third one on this list here is velocity. And this has a real interesting characteristic because it has a stringent requirement from the time the data is created to the time you get actionable insights. So the expiry of the data set is very relevant. And the use case is really stream data. Think about IoT that is created at high speed and only relevant for a short period. And the solution requirement it really creates is to capture that stream data and being able to run either real-time analytics on that data or save it for offline processing later on. So if you look at these V's, when your data comes available, it is sometimes large and complex to process. So you have to start innovating how you collect, store, and process and analyze and share the data. Very quickly, there is a lot of noise in the market around big data analytics. There are a lot of market analyst reports shared by IDC, Gartner, and Forrester. But one I want to pick out here is around data warehouse and data lake in the cloud and BI platform in the cloud are the top 3 types of technologies enterprises are planning to use. So that may match with your objective as well, but we are actually interested to hear your motivation and what your individual plans and challenges are. So please feed back to us through your contacts or through the email at the end of this presentation, so we can see how we can plan to help you. So let's start with the data lifecycle. So when we think about a data lifecycle project, regardless of what data system you're building, there is always a common pattern you would follow. So it could start with a BI system that builds on top of a data warehouse. It could be a distributed file system such as Hadoop that batch processes large files, or you're enriching your data by asking more elaborate questions with a machine learning application. But the first questions you need to think about is, how do we get the data from our many sources? And in traditional IT, that's usually on-premise. How do we properly stage the data and apply the right housekeeping? But also, what level of cleansing does the data have to go through before I can provide that data set to our users? And how do you drive analytics and visualization and create meaningful report for the decision making? So in the following sections, we are going to step through the cycle, and we will mention some tools and services and illustrate the theory in a very simple demo. So the first stage is really the data ingestion. And this is about mechanisms of moving the data. And data sources include transactions from ERP systems, clickstream data, log files, devices, and think about your disparate databases that needs to be migrated over. And traditionally, I mentioned that a lot of these sources are on premises. So we need to think about the destination as well. What is the destination? Is it some sort of storage or a database? And when we're retrieving data from a source at rest, like a relational database, it's way different than from a source that is in motion, like a real-time clickstream. The data structure will influence the collection method. I mentioned structured data, semi, or unstructured data. Think about, is the source immutable? So think about IoT telemetry data like temperature that changes over time, or clickstream that is part of real time. The collection methodology of uploading batch data, so offline batch data, is completely different as well. So we mentioned Hadoop earlier. So think about a cluster that is idle for a long period of time, and suddenly massive amounts of data are pushed through to get some results. So destination, where is the destination? Is it going into a data warehouse? Is it populated into a data lake? So in AWS terms, that would be an S3 object store. Or are we passing it through for further downstream analytics, ML, for example? So all these questions need to be considered before really choosing the right tool for the right job. And just one thing to remember as well, that these services are not mutually exclusive for a use case. You can use those building blocks in no particular order. And one point of advice is, start with any order that is relevant to your business and your business priorities. So you could start with the data lake and add a data warehouse, or vice versa. And don't try to get all your data sources in at once, and match that to your business priority. In our world, we like to take the MVP approach, which is the minimal viable product. So focus on your first case that match your business priority, and then move on to the next building block once you're successful. And once you get your cycle running and you see the business value, you can really think about different use cases and different functionalities. So don't get intimidated by the vast amount of services available. Focus on the ones that serves your use case, and use the cloud advantage as well, and experiment, try those services. You can fail fast and unprovision quickly. There's no risk at no cost. So you're not losing much investment. Further to the data ingestion, if we just look at the traditional sources we mentioned earlier, and I said that most of them reside on premises. So we need to think about how we connect our on-premises environment to the cloud. So establish the network connection from source to the target. And we offer services such as Direct Connect between sites and VPN for connection tunneling to connect to your, let's say, on-prem ERP system. Just a word around the databases. We provide you with a migration and assessment toolkit, which is made of DMS, which stands for Database Migration Service, but it actually does a little bit more, and SCT. So DMS, it's in summary, a heterogeneous replication engine that helps you, copying your data from one schema to the other. SCT is a schema conversion tool, and what you could do is really point your schema conversion tool to your source and point it to your desired target, and then you can do run an early assessment of to find out what complex migration complexity you're going to face. So it will give you a auto conversion ratio, and give you visibility of how much refactoring manual coding you are to expect of moving that workload. It's worth mentioning that these tools work bidirectional, so you can even replicate out of AWS as well. So the other data types here on this list are around media, big export files, log files, which are typical candidates for S3 object data. So with large export especially, we see many ways to import the data via your S3 interface. And we have, for the very large volumes, which you want, which challenges your network connection, we have device services available to you. You may have heard of the Snowball and Snowball Edge devices, where you can especially move large volumes of data and thereby take the pressure from your network links. So if you look at the bottom right, so when it comes to the IoT sensors, clickstream, telemetry type data, so we're looking at stream data, we're going to address that with our Kinesis suite software. So Kinesis data streams, you can bring the streaming data in very effectively, and Kinesis maps it really nicely to your scenario. So, and I'll give you an example. So when you define the data stream within Kinesis, you're actually defining how many records you're approximately expecting. So let's say your IoT device is generating 1,000 records per second. You only need to worry about the record throughput. So you configure the parameter with your 1,000 records, and should that change, so let's say that increases to 10,000, you just change that parameter, and vice versa. If you want to shrink it down, you can just configure the parameter. And the beauty is you don't really have to worry about the network architecture or the compute infrastructure that needs to facilitate that requirement. Yeah, so you're leaving the heavy lifting to us. Now, if you want to take that data stream and save it and process it later for offline processing, you can use Kinesis Data Firehose. So let's say you're collecting your smart city IoT data and want to feed and train a machine learning model for advanced analytics later. You just set up your data Firehose, collect the data using producer libraries such as Flume or Logstash to publish in the Firehose, and then Firehose takes the data and writes it into your desired target. That could be an S3 object store in your data lake, a data warehouse, or even an Elasticsearch cluster. So again, Firehose is doing all the heavy lifting once the data hits the pipe, and stores the data in the repository of your choice. One popular collection open source technology in the market is Kafka. And last year at our annual conference, reInvent, we introduced Amazon managed streaming for Kafka, which also takes all the heavy lifting away. So for example, you don't need to worry about standing up your own brokers. It provides multi-AZ for HA, as many other AWS services do. And all the configurations that make Kafka enterprise and production grade. So just stand up your cluster in your VPC, and it's also different to Kinesis because Kinesis actually works on regional level. So I mentioned Kinesis. So I mentioned IoT a lot and temperature data, telemetry data. Kinesis also nicely integrates with our IoT services available, such as IoT Core. So you set up your IT broker, which supports, for example, the MQTT protocol, which is often used in resource-constrained devices. And the broker receives the data stream, and you can forward it to Kinesis Firehose or to multiple destinations based on the rules you have defined. So in summary, the key thing is really these are all loosely coupled architectures. So we are following, the microservice architecture, the right tool for the job approach. And the way the data is really collected, it depends on the analytics that is required. So let's stay with real-time data movement for a second and review that architectural diagram here. So on the left-hand side, under one, you can see we have producer libraries. So if you want, you can use the Amazon or AWS native ones. So there's an AWS SDK, the Kinesis producer library, a mobile SDK as well. However, if you prefer using an open source product, you can use Log4j, Flume, or FluentD as well. So that option is available to you. And when you start provisioning, and populating your data lake, so I gave you the example with Kinesis data streams where you can capture the records. You can then use Firehose to save it for further processing. And at that time, you're actually storing the data definition in AWS Glue, which helps you to cataloging your data. And from there, you can just start off different processes. So you can start processing your data offline with, by triggering the creation of environments, let's say through a serverless compute function represented by Lambda. So that could be kicking off a transient cluster that is created, or you use real-time analytics such as Kinesis data analytics or Spark on EMR, or even if you have custom code available on your virtual machine or EC2 instance. So all these services give you like a first business insight before you attempt to create any architecture or data flow that is important to focus on the business problem. Now we talk about the right tool for the right job, and there are like all these different engines available to you. So how do you select the right tool, and how do you select the right service? So the two aspects you need to look into is the data structure and the data access pattern. So for SQL, that would translate into, is the data highly normalized in a highly normalized table structure? Does it require a fixed schema, let's say a schema on write? And is the data processing based on an ETL approach where the transformed data is mapped to an existing schema, or does it use a lot of joins? So all these questions help you to elaborate, okay, I need potentially a SQL-based platform. Right, so in terms of access patterns, do we have multiple users reading the same objects? You could consider some in-memory technology. Are we talking about key value stores, which are great for storing data that needs to be quickly stored and queried? So this could include session data, tracking data for car locations, for example. Or do you have telemetry data, IoT temperature data? There is a time series database available which addresses the time interval aspect. So different data structures often define different types of storage. And there's even more parameters to consider. But again, if you want to start, focus on the use case and focus on the shape of the data. If you need an append-only system of record type application where you're not changing the actual record and only appending to it, you probably want to look in something like a ledger database where we offer an Amazon QLDB database. And I'm not going to dive into each of those categories here, but you can get the idea of how to really approach it. So use cases, shape is important. But what's also really interesting is actually price. And price is an interesting indicator as prices are designed against the use case. I give you an example. If you're deciding not to use Kinesis data streams to collect your clickstream data as previously described, and you decide to write individually to S3, so via put methodologies, you may not experience the same economies as using Kinesis data streams for it. Yeah. So the use case is kind of matched against the pricing model. So going back to our flow, we have now collected the data and we're storing it. So we need to think about the questions we ask in the staging phase. So what type of data validation needs to be performed? And this could really include a specific type of notification we want to see as data hits the pipe, or functions I want to trigger. So I mentioned, a Lambda serverless function that triggers the creation of an environment to offline process data. Or do I want to detect anomalies which I want to capture? So let's say something comes in, a string comes in, and certain values don't match. So a very popular methodology in fraud detection. Data governance and data engineering play an important role, and this is really about cracking the nut where the effort really lies in the data engineering. And we just wanted to help you to focus on that task while we focus on the undifferentiated heavy lifting. So as data comes in, you can auto tag the data as well. And in the security section at the end, I will dive into that a little bit more. There's some really powerful stuff available with the object data tagging. So in staging, the main thing is really that you can crawl and catalog your data and apply the required housekeeping tasks prior to making it available to the users. So when it comes to the cleansing stage, it's really important, to transform the data so it can be used for downstream analytics. Many organizations have a common data model, and sometimes this clashes with other sets. Different fields that call, the same value, for example. In our little demo, we are querying a location. We're querying a location with longitude and latitude, but in the original data set, it's designated with X and Y. So there is a little task for some data quality services before we pass it on to downstream analytics. We also need to ask how to optimize the data. Are we optimizing towards read or write queries? What will the data cleanup look like once the data is processed? Can the data be deleted if not immutable? What type of removal or archival principles apply? Just some guidance on that as well. Try not to remove any raw data. So creating a lifecycle policy helps you to move between tiers. And so, your data becomes a source of record, which means you know when the data was ingested, how it was cleansed, and stored. And this is also a practice you start working with when you're using open data sets where the data is provided by someone else. So with this, we're going to take a little break from the slides and jump into a demonstration. So for this demo, we're using an AWS open data set, and the public sector has with their open data set, a very valuable asset. And for this demonstration, we're going to use Cornell's climate data set, which is hosted on our AWS open data platform. And the AWS public dataset program covers the cost of storage for this publicly available data sets. I think there is a session next week or later on, which will dive a little bit more into the subject. So yeah, just a quick overview here. You can see how we're moving, not actually moving, but accessing data provided to the open dataset platform. So that's the Cornell climate data. And let me just, so the first thing we're actually going to do, we're going to create a table using an AWS glue job. And that table provides us with a catalog view. So as you can see here, we're accessing the data lake location where the climate data sets resides. And just by cataloging the data and crawling the data, we get an early view on the columns. And so for example, you have like level here, which represents the level of atmosphere. I mentioned the coordinates represented by X and Y. Then you have like all the coordinates available to you as well. So the actual value observation, so the degrees, wind speed. So we already have some information now available where we can run some queries. Just to let you know, before we did any type of optimization, we ran queries directly on the data set, and that took us over an hour to perform a query. And especially when you're moving into a pay-as-you-go model, this query time translates into a cost. So once we actually converted the data into Parquet, so into columnar format, once we applied partitioning to the data, that query performance, and using actually compression as well, went down to 3 minutes, as you can see here. So I've already run the query because there's no point of watching the query run. And that's a massive win in terms of query performance and cost savings. So this is really going back to the principle of saying, before we present the data to our business users, it should go through some level of cleansing and data preparation. And later on, once the user knows they're only querying a specific set, they can just have a very targeted view. So they can use the materialized view and maybe not necessarily don't need the entire data set. Yeah. So it's just like some thinking around, try to optimize the data formats, and there are a lot of tools available to you. So we performed everything here in Redshift at Spectrum. Which is worth mentioning, we haven't actually copied any data into Redshift. So with Redshift Spectrum, you are using the engine and performing the queries against the data set where it lies. So the objective is really not trying to copy too much data around. So you can copy the query and really run the query in Athena for some ad hoc analytics as well. I mean, Redshift is obviously a better use case to run much more elaborate, complex queries. So this is really all about looking at the existing data and doing some queries there. But we said about, once you've prepared your data, it's really worth optimizing a little bit more. So just on the Redshift Spectrum thing again, so the beauty really is that Redshift supports Org and Parquet. And yeah, you can copy the files into the database if you want. And so when you run your initial queries on your data set, without using partitioning, compression, converting into a Parquet, it will scan the entire data set, which can take hours. And yeah, so it uses external tables as well to query the data that's stored in S3. You can create an external table storing it in Redshift, Glue, Athena, or even in an Apache Hive metastore. So again, why partitioning? When you partition your data, you can restrict the amount of data that Redshift Spectrum scans, and you can filter on the partition key. And you can partition your data by any key. Yeah? So a common practice is to partition the data based on time. So year, month, date, hour. What's also interesting, if you have data coming from multiple sources, you might partition by a data source identifier and date. So let's say we want to pass it on to downstream analytics and do a little bit more with it. And this is really taking a CSV export and importing it into SageMaker. And in here, usually data scientists prefer Jupyter notebooks to create the data frame, and they apply libraries, also called pandas. And I'm not going to dive too much into the ML element here, but you can see that yes, you can do some data preparation and then visualize the data. And once you have done that, you can just move on into training a model to do some predictions. And in this work in progress environment, we are focusing on forecasting. So yeah, so you get the idea of passing really the data to the different stages of processing. So the idea really was here to show you, just with a couple of hours of tinkering and experimenting, what you could actually achieve with your data sets. And not once I had to think about infrastructure and provisioning, and could see some early results. So just to summarize on the analytics and visualization. So data analytics is really the stage where organization can identify how to effectively manage the budget, potentially reduce costs. And analytics in combination with visualization delivers decision makers insights, which could help them transforming their organization. So that could include identifying the unmet, unconsidered needs, and optimizing processes. Data-driven decisions, that can give decision makers a backup who usually rely on the hearsay and instincts when making choices. Yeah. And so the key considerations in this phase is really the requirements for analytics being clearly defined. What is the output being aligned to the use cases, and the consumers of the data within the organization, should really have valuable reports with actionable data. I want to just quickly dive into some customer references. At the very beginning, I mentioned FINRA. So FINRA is a US financial industry regulator, and they are leveraging different tools for different jobs. They're collecting from many different sources with many different formats. So for example, from the New York Stock Exchange to NASDAQ. And that's mostly structured data sources, so data from databases. But they're also collecting a lot of unstructured data, such as brokerage reports, and that could be about 1 million documents a year. And I mentioned earlier that they're using a natural language processing service, Amazon Comprehend, to convert their unstructured data into structured data to do sentiment analysis and entity extraction, etc. And that really helps them to dig out a treasure out of their unstructured data that is often really unusable archive data. So if you look at the middle bits, so in terms of the architecture, they're leveraging EMR, so the Hadoop service, to perform interactive queries. And EMR provides them with their surveillance analytics as well. And Redshift Data Warehouse is used for running predefined queries. And the data modeling, if you look at it here, is very similar to what we described earlier. So data lands into S3, data is preferred, different analytics tools and services are serving a different use case, so and answering different questions. Security and compliance is also very important to FINRA. So the architecture is designed for security and compliance. So you can see we're using VPCs. So these are virtual private cloud architectures to provide logically isolated sections. And then we have VPN to provide secure and private connection tunneling. And encryption is being used for data at rest and in motion. And for auditing, governance, and compliance, they use CloudTrail and database auditing as well. Hearst, who is not a public sector customer, so they're a major media and information company, and they provide different formats such as magazines, newspapers, and TV. They collect crawl data from different websites using Kinesis data streams. And in the top fork, you can see they're storing for offline processing, and in the bottom, they're performing real-time analytics where they create dashboards and materialized views through a Lambda pipeline. So they're leveraging serverless tech, and all is stored in a NoSQL DynamoDB database. So which analytics should I use to answer that question? Just 1 second. So again, start looking into the use case and the business requirements, but also look at the time frame of the question. So is it streaming? Is it real time? Does it take minutes to hours? Or are we looking at milliseconds for your analytics? So consider those things as well. And another bit of advice, the more you can leverage a managed service solution where AWS takes care of the undifferentiated heavy lifting, the more you will be able to focus on what matters for the business. So don't worry about infrastructure. And even when looking into, which analytics tool should I use, again, focus on the use case. And I'm not going to dive into too much detail here. You can see like Athena for some ad hoc analytics. I talked about Redshift Spectrum, how you can just run the engine without copying the data into Redshift, and then Amazon EMR splits down into different use cases here as well. And which stream processing technology should I use? Similar principle applies here. So for example, if you want to use Kinesis Analytics, that allows you to run the Flink application, so you can really run SQL queries on your real-time data. So what does that mean? People who understand relational databases and SQL can quickly apply this to real-time analytics queries, and for example, do grouping of anomaly detection. But people who want a bit more control as well, so people who need the low-level coding, they can use Java, Python, and .NET Core. So one of the newer services I want to quickly mention is Lake Formation. And Lake Formation automates many of the steps we discussed, allowing customers to get started with just a few clicks, from a single unified dashboard. And customers can really build quickly some data lake environments. So with Lake Formation, you can move, store, catalog, and clean your data faster. So how do we do it? We simply point our Lake Formation service at our data sources, and Lake Formation crawls those sources and moves the data into your Amazon S3 data lake. And Lake Formation organizes the data in S3 around frequently used query terms and into right-sized chunks to increase the efficiency. It also converts the data, changes the data into formats like Apache Parquet and Org for faster analytics, as we discussed briefly in the demo. Lake Formation has also built-in machine learning to address deduplication and to find matching records. So that could be, two entries that refer to the same thing, and by that you can increase the data quality. It simplifies security management as well. So if you look at Lake Formation to centrally define your security, governance, and auditing policies, you can take that and enforce those policies for your users across the analytics applications. In terms of self-service access, you can build a data catalog that describes the different data sets that are available, along with the groups of users that have access to each. And this makes it really more productive by helping your users with the right data set they require for their processes. And you can give granular permissions. So that means you can give permissions on columnar level. So really you can restrict user access not just to a specific table, but also to a column. In terms of auditability, it provides you with a lot of audit of activity and access in your data lake, and we will touch on that very soon. But before that, I want to just touch on the last element and last stage in our life cycle, which is data archiving. And this is also important for compliance and maintaining a system of record. And in the archival process, we want it to be easy. So that means we don't want to worry about configuring the tape libraries, and it should be more about the storage of your data and less about the management. And this is storing across different classes of storage, and also focusing on setting up a lifecycle policy. And there are also many new features such as intelligent tiering, which helps you monitoring access patterns and then actions the movement of data between tiers. And by tiering your data securely, it really helps you drive the cost down by and not necessarily losing the data. Before we talk about security, just a quick recap on our shared responsibility model. Just for those who are not familiar with the approach. So in essence, that's AWS is really responsible for the security of the cloud, which includes everything from the concrete of the data center facility to the physical security up to the hypervisor layer. And customers are responsible for security in the cloud, so concerning the data they put in and the handling of the data. So this is really encryption and depending on what service you're using. Obviously, if you're using EC2, you need to look at patching and all these things, but it's a moving target. So if you decide to run a managed service. But when it comes to securing a data lake, and not just securing, but also protecting and managing it effectively, these are the key elements I would revisit and consider. So when you're building an analytics environment, and especially a data lake environment that serves as a centralized repository, it is really important to implement a stringent security model. And on AWS with S3 as its core, we have the following features available to you. So first of all, we have access policies and identity access management, IAM. So you can manage your S3 object resources using policy options. So all buckets are private by default. So that means the AWS account that created that bucket can access them. And then you can use resource-based policies, which are bucket policies and access control lists, also known as ACLs. And then you have access policies which you can attach to the user. The combination is really used to manage S3 buckets, objects, and also other resources. For data lake environments, we recommend using user policy. So permission to access data sets can be tied to roles for data processing, using a specific analytics service, and tools users will use. And user policies are associated with IAM, so identity and access management, users, groups, and roles. When it comes to encryption, we look at S3 and KMS, Key Management Service. So if you look at the first bullet, this is really about who can see and access. But if someone gets inadvertently or maliciously accessed, you want to make the data unusable. And this is achieved by using encryption. And S3 supports multiple options. So KMS helps you scaling and better management of your centralized keys. KMS also integrates with other AWS services, which makes it very easy to encrypt the data stored in those services. It integrates with CloudTrail, so which enables you to audit who used which keys on which resources and when. And so the data lake on AWS, we said, is actually using multiple encryption keys, and one of them being server-side encryption, also known as SSE, and the client-side encryption. So SSE is the at-rest encryption for data written to S3. So this is happening, the encryption happening on object level. And the client-side encryption is really the data objects are encrypted before they are transferred to S3. If you combine those two, you get the highest level of protection. And data lakes are really a complex environment. So coordinating key management is a complex task. So we would recommend really to use KMS for that. And you can extend that further. So if you want to do some, realize some check-in and check-out mechanisms for your data lake assets, you can use API Gateway and Cognito and combine those together. Now, if we actually look at the platform and with S3 at its core, we need to be able to protect against corruption and loss. And S3 provides you with a high durability of 99%, 9 times 9. So what does that mean? It actually means that you get 4 to 6 orders of magnitude what customers are currently experiencing with on-premises solution. It protects you across multiple availability zones. So one zone consists of more or one discrete data centers, which have redundant power, connectivity, and each AZ is an isolated location. And S3 also provides you with versioning of multiple copies. So that helps you to protect against deletion and corruption. And S3 also has lifecycle management, which enables you with long-term retention and moving your data to lower tier cost storage. And S3 also provides you with geo-replication, should you as a customer require this. And this is not something we would do, obviously, without your consent. And the data in transit is usually encrypted with SSL. The last thing I want to mention is the object tagging. And data lake solutions are multi-tenant solutions. So you have many organizations, line of business, users and apps. So it's important to associate data sets with all those entities. An object tag is a mutable key value pair. So each object, S3 object can have multiple tags. I think it's up to 10. And if an object contains, for example, protected health information, so PHI data, a user or app using this object may tag it, using a key value PHI equals true or classification equals PHI. And the object tagging can be used in conjunction with IAM to enable you with fine-grained controls of accessing of access permissions. And a data lake user or group can be granted permissions to only read specific objects with specific tags, and those tags can be also combined with lifecycle policies. Tags can be also combined with CloudWatch and CloudTrail, so this helps you with the monitoring and auditing. And with the last point, you obviously want to make sure that the services you're using also meet certification and compliance requirements. So let's quickly review some of the architectural principles. We talked about decoupled systems. So the ingestion point shouldn't create a dependency, how the data is being processed, stored, and further analyzed. This helps you to scale and easily extend your environment. It helps you for your dev teams to work autonomously. So especially, in the new world where development teams are dispersed and potentially in different time zones, and you're not impacting the downstream analytics. When you're storing your data, you should try to use a standard format like JSON, CSV, Parquet, ORCAS. And what does it actually means is proprietary types, they can silo your data. Leverage managed services as much as possible, and serverless. So you can focus on the activities that generate business value. That means less admin, we do the heavy lifting. And a lot of our services are built on open standards. So we looked into Athena, which is built on Presto. So if you have a Presto query, you can use it right away, and so you don't have to worry about provisioning a complex Presto infrastructure. And as we said before, open source has many benefits, but it can be sometimes complex to implement. And this is where we give you the services, the wrapper around those open source services to give you the enterprise grade enhancement and increase thereby your manageability experience. Focus on immutable data sets. When data is ingested, try to append on. And this is a practice you obviously adapt when you're dealing with raw data from different sources. Big data doesn't mean big cost, so it can be costly on-prem, but with AWS Cloud, you can just benefit from a pay-as-you-go. All the other benefits in terms of elasticity apply. Start small, on demand, and enrich your data further. By using machine learning and training models to gain more elaborate insights into your environment. So we talked about the challenge at the beginning, just to summarize that quickly. So we talked about that data is dispersed and difficult to access. We looked how data can be linked into AWS, transformed, and passed to purpose-built analytics, and how the copying of the data is not always required. Limited views, we provided different views, use different engines, and run queries across data sets. Resource constraints, not once we had to look into the infrastructure provisioning and the configuration efforts, and we just could establish something with a couple of hours of experimenting. Elasticity, only pay when the queries are running, leave the data where it is, just don't copy stuff around necessarily. And the governance and compliance aspect, everything is in an environment where you have full control and visibility of the data, so with compliant and certified services. Now, with this, we are really coming to the end of this presentation, and I hope the proposed data lifecycle structure resonates with you, and maybe there was something new you could learn, and hopefully this inspires you, to think about optimizing processes and looking into different methodologies. And yeah, so I would like to say thank you very much, and let's open up the session for any more questions.
Fantastic. Thanks very much for that, Abir. So I think we've got time just to squeeze one question in there before we wrap up for today. So I'll just pick one here. It's a good question, actually. So can you give any guidance or sort of best practices about how to sync data from a range of different devices?
I think when syncing data from different devices, probably we need to elaborate more. I mean, where is the data coming from, and is it really about talking asynchronous versus synchronous? And I think it depends on a couple of things. It's just, first of all, what is the actual use case, but what is the infrastructure available, and then really working back from the use case and the environment to dissect of what tools and services we may require. I know it's a bit of an ambiguous answer, but we would really need to understand what type of data are we actually syncing. What is it? And I think you can't just make a general comment on, okay, and this is how we're going to sync the data. So this is going back to my point of, let's look at the business problem and try to understand, where is it coming from? What is the frequency we're trying to sync as well? How frequently is the data changing?
Okay, yeah. Fantastic. Thanks for that. Well, like I said,
yeah. If there are any more questions, there is an email for people to ask. So yeah, thank you very much.
Yeah, absolutely. Please do drop us a note at the email address that's on the screen now. In the meantime, thank you very much for taking the time to join us today. Thanks very much to Abir. Thanks very much to Charlie. And we'll put a quick poll up on the screen in just a second, just to get your feedback on how things went today. But otherwise, from myself and the team, thanks very much, and we'll see you next time.